Okay, why don't we get started? So good afternoon. My name is Thomas Raibert. I'm the Executive Director of Mass Robotics. I want to welcome you to Robot Stories. This is actually the fourth version of it. And this series was co-produced by the state of Massachusetts and Mass Robotics. And it's really here to introduce you to some of the amazing roboticists that call Massachusetts home. Last week, we chose to postpone this interview in support of Black Lives Matters and the hashtag #ShutDownSTEM. We at Massachusetts are a strong believer in STEM programming and activities for students, regardless of color, to get them focused on the technology and get them excited in the technology. And we've been working with groups like the Timothy Smith Network and BOSTEM to identify schools to host workshops and hands-on robotics activities. We work to inspire all students to enter the STEM fields, and it's a talent that's desperately needed as the robotics community continues to grow here in Massachusetts. Robot Stories is one example of the things that we do to encourage students to get involved. And as I think hopefully many of you know, Massachusetts is really a place where it is known to turn kind of problems into real-world solutions and using technology to help. Robotics is a great example of that, and I think you'll find that robots exist today in almost any field and will continue to grow into many more fields. And the future is going to play, the robotics are going to play an amazing role in our future, and we want everybody to be involved. And so today, we're really excited to be talking with Mark Raibert, who is the founder of Boston Dynamics. Boston Dynamics makes some of the most fascinating robots in the world, and their videos garner millions of hits. And so we're excited to have them here and get started with this series. Before I start, I just want to mention that we're going to be showing a couple of videos. It is best to have to close your other applications that are on your system and really have this one on, because sometimes the videos will pop up behind those other applications. And also, before I get started, I want to show a new video that the state has created that highlights some of the Massachusetts robotics organizations and the people that are creating and using robots in their everyday jobs.
I think technology can address some of the problems we come across in the world, create a more efficient way of doing things, and also a safer way. I think robots play a big part in that.
So we have these blocks. Where would I go if I want to tell Root to draw? Shavana, do you remember?
Oh yeah, I think it's in commands.
Exactly.
Humans are innately curious and they want to figure out how the world works around them or how to solve a problem. I think robots are on that continuum of innovation.
There are just so many different forms and shapes that robots can take. They can help in almost any industry.
So the AD Makepeace company was started in the mid-1800s. It quickly became the largest cranberry company in the world, and we're still the largest cranberry company in the world today.
We make parts for medical, aerospace, military, automotive. The previous process that we had, it was like being glued to that machine for 8 hours to make a certain amount of parts.
I'll eat these all day long.
Normally we'd have to walk out there, grab a square foot of vine, count your blossoms, kind of get an idea of what your crop is going to be. To have the drones be able to do that, that's all automatic. Being able to look at damaged spots, being able to watch temperatures, being able to watch moisture, all those things will make it easier to get your job done.
With the robotic machine, it gives me that time back to do something that's more productive for me or more productive for the company.
A robot is an extension of human capability. whether it's extending the capability to be more efficient, to measure things in more precise manners, or extending the capability to explore the world.
All right, engaging in 3, 2, 1.
You will see everything from drones to self-driving vehicles, walking robots, and we're excited that it's being developed here in Massachusetts.
Massachusetts is an ideal location for a robotics company to get established and succeed.
Because we have such a diverse group of people, we're able to think in different ways and tackle challenges.
We have the breadth of talent. We have the investor community. There are manufacturers here that understand the hardware.
We have the facilities to design it, fabricate it, and then take it out in the field and use it in our operations.
All of that supporting infrastructure is here, as well as a very open environment for the technology.
They know drones, we know cranberries. It's trying to get those two informations together to figure out what is the best.
And it's humans working side by side with robotics.
It's very exciting. It feels like the future.
And it's all here in Massachusetts.
So I think you've seen from that Massachusetts is really a global leader when it comes to robotics, and we're excited to have Mark Raibert here joining us today. Mark is the founder, former CEO, and now chairman of Boston Dynamics. And Boston Dynamics is a robotics company known for creating things like the Big Dog, Atlas, Spot, and Handle. Welcome, Mark. And I'd also like to introduce Cheyenne Genty, a former Boston Public School student who is now at Canton High, and he will be interviewing Mark. Before we get started, I just want to say that we'll also take questions during the seminar, and if you'd like, you can just type them in the questions tab. It should be on the right-hand side of your screen. There's a tab called questions. Type it in. If we have a chance to get to it, I know that our student has a lot of questions of Mark, and Mark has a lot of exciting videos. At least I'm hoping he does, because I've seen them, some of them, and it's really great what he does. So why don't I turn it over to you, Cheyenne, and take it away.
All right. Hello. So as Tom said, I'm Cheyenne, and I was a student in Boston at the John D. O'Brien School of Mathematics and Science. So now, though, I'm at Canton High School, which is, again, in Canton, and I'm a rising senior. So I'm interested in robotics, computer science, those areas of technology. And I was glad to hear about Mark, who I'm interviewing today. So how are you, Mark?
I'm good. How you doing, Cheyenne?
I'm great. So to get some few informations off, so I'd like to tell the audience that Mark, before we get started, so Mark is the founder and I guess CEO of Boston Dynamics. So he went to Northeastern and graduated with an electrical engineering degree, and then received a PhD from MIT, which is a college I want to go to. And he was a professor at electrical engineering and computer science at MIT, and then associated professor at computer science and robotics at Carnegie Mellon University. So let's get started with my first question. So why did you decide to develop self-balancing hopping-style robots?
So when I was a graduate student and started in robotics, I was working on robot arms. An arm with a hand that would go around and pick up things and move. And I went to a conference as a graduate student. It was a conference about animals, locomotion, animals with legs that would walk around in the world and run and, all the things that animals do. And there was one talk from a robotics guy who showed an early legged robot. It had 6 legs. It was very large. It moved very slowly. And I watched that thing and I thought, man, this is wrong. Animals, when they move, they fly through the air sometimes. When they're when we run, they bounce on their springy legs.
Yeah.
They're moving dynamically all the time. And this robot was kind of moving so slowly, with always making sure that it had enough feet on the ground so it wouldn't tip over. It was like a table, but with moving legs. And I thought, man, this is on the wrong track. And so I went home and thought about it for a while, and I thought, well, let's see, what's the opposite of that? and I ended up, working on pogo stick robots. A pogo stick only has one leg, so you don't have to worry about coordinating lots of legs. And it has a spring, and so there's this interesting rhythm that it gets into when it's operating correctly. And that seemed to me to be very much more like the biological system. I have a little video clip of one of the very early hopping machines we built.
Oh, okay.
This was this video was made in 1983. It's at Carnegie Mellon. So I was a young professor there. And this robot's balancing itself. Now, in those days, we had a whole room full of computers controlling it. So through that wall in the back, there's a big computer, and you notice that there's a hose that has both hydraulic power to a big pump and a connection to the computer that made it balance. I think one of the interesting things is that we used what we learned in that pogo stick to build some other robots. This is a two-legged robot that went, I don't remember how fast it ran, but maybe 15 miles an hour. Here you see it setting a record. We made it climb stairs, sort of stairs, and jump a little bit.
So, just building up, I guess, one leg, two leg, and then four.
Building up, exactly. Yeah. If you can get an underlying key idea, you can use that idea over and over again.
Okay. So you were a professor, at Carnegie and MIT. So what made you decide to go from academia to business?
You can turn off this video now, I think, if you want. There were a couple of things going on. One is I was at that point in my life. I was in, my early 40s. And when people get to be in their early 40s, they get restless. I think if I had been a business guy before then, I would have switched into academia. In this case, I was in academia, so there was, I wanted to do something different. That was one thing. But also, we had this opportunity to take some of our robots out to Hollywood and have them in a movie. And so why don't you play that next clip? This is a little clip from the movie Rising Sun. That's a famous actor, Wesley Snipes, so you may know. And in a second, you'll see Sean Connery. So it was a big movie. And there's one of our robots in the background and one of my graduate students. And I had other students and people there on the set. And that actor is sort of playing a person like me, a robot. But the key message is that when we did this, it was really hard getting the robots to work out of the lab. They worked great in the lab, but when you took them out in the field and you had to deal with the real world, it was a much different beast. And it got me thinking, about the difference between a product. When someone makes a product, they put it in a cardboard box and ship it all around the world. And someone who doesn't know anything takes it out of the box, and it has to work. And that kind of set me on the path of saying, can we do robotics, not as a lab thing with all very well-trained people, but can we democratize it and make it more available?
Okay. So what were some of the early things you worked on, with the robotics, early invention, stuff like that?
Well, I was already a graduate student. When I was a kid, I was always building stuff. My father had a lot of tools in the basement. He was an accountant, but I think he wanted to be an engineer, and he wasn't. And so he took it out in the basement, and I got the benefit of that. So I was always building stuff as a kid, not robots, but other contraptions. And then when I was a graduate student, I was actually studying the brain. I was studying animals and how animals work. But one day, I went back to one of my professor's labs, and there was a robot arm sitting out on the table in about 1,000 pieces. And from that moment on, I was a robotics guy. I switched out of that program into the other one and started studying robot arms. And then, as I told you, I got involved in legs and started building the the pogo stick, and then, you know, over the years did many, many different kinds of legged robots.
Okay. I mean, that's interesting. So, like, the professor, I guess, or inspired you, you know, to go into that field?
Yeah, he was, you know, he had a robotics lab. It was at MIT.
Mm-hmm.
So I was a graduate student at MIT. Then I went to CMU, and then I came back as a professor at MIT. But, you know, when I was a graduate student, they had a lab where they were doing all kinds of interesting work. It was the artificial intelligence lab, which is sort of merged these days, or morphed into the what's called CSAIL, which is Computer and Artificial Intelligence Lab. But that was the earlier version. And, you know, the professor, that professor was Bertold Horn. He was interested in computer vision. And I remember going back and seeing that robot arm, a really old, creaky one. But man, it really got me excited.
Okay.
I guess the lesson, if I could start lecturing, I'm hoping there's students on the line here. You know, you should do what you love doing. I think that's what it boiled down to for me. There were a lot of more practical things maybe that I could have done, but this looked like something that was just going to be totally fun, and it has been for many, many years.
Yeah. So you've built like some of the world's most advanced robots, such as, you know, Big Dog, Atlas, you know, Spot, and Handy. So you now offer like Spot as a product. You know, I saw the video on YouTube actually, I think yesterday.
Yeah.
So like, what are some things, you know, that Spot can do?
So the fundamental thing that Spot is designed for is to be a mobility platform. That is a robot that can go lots of places. It can go in normal places that are flat, but it also can climb hills, go over a dirt pile, climb stairs of all different kinds. And that means it can go to, you know, lots of places in the world. And we've designed Spot to be a platform, which means that you can put all different kinds of payloads on it. It's sort of got a mechanical roof rack on the back. So even if you don't have the perfect thing, you can stick it on there and put some clamps on and clamp it on, and then later manufacture something that fits. So, you know, being in robotics, being the developer of robots is like a journey. You know, you start out with initial ideas like the pogo stick. You develop more and more capability. We are where we are now. Spot doesn't do everything, but we're hoping by having it be a platform that people can use for a variety of different tasks and be adapted, that we can learn about what's needed and, you know, move to the future. And then sometime in the far future, the robots will be much smarter, much, you know, better designs. But we're on sort of the midpoint of doing that. And Spot's real goal is to let as many people as possible have a robot that has capabilities and let their ideas about how to develop it further and apply it to tasks can be done.
Okay. So basically, like, so what are like some, like, I guess, places, you know, or projects, you know, you could use, I guess, Spot in, you know, to like in the field essentially.
So I have a little video that shows, you know, over the last year, we've been working with what we call early adopters who have the robot. And let me show you a few of the things that they've done. This is a British petroleum refinery where we have Spot carrying methane sensors. So this lets the robot detect gas leaks. It has a camera and gauges. And the basic mobility of the robot lets it get around in an environment like this. You know, you can't imagine almost anything else getting around in a cluttered space like this with all these narrow, windy stairways. And, you know, the world is full of facilities like that. And we think Spot's going to be very useful in doing some of the instrumentation and measurement jobs. This is a power plant where they can't do inspections because it's too dangerous for people to go in there. And so they only do it once a year when they shut down. And we're hoping to use Spot to be able to do those inspections year round.
Okay. Yeah.
This is a construction site. There's a lot of people who would like to have automation on construction sites, be able to measure progress. Here we're recording 3D data about the status of the construction site with that special Faro sensor. And then you can build a virtual model of the space. And now a manager can sit back in his office and look at data from the remote robot and it tell them, what's going on the site.
Yeah.
And this is a company who's exploring the use of Spot to do agricultural applications. Here they have it working with some dogs to herd sheep.
Yeah.
You should watch this online because it's a little jerky here, but it's really and we're also working with some entertainment people. This is Cirque du Soleil, who's been exploring whether our robots are expressive enough to work with people and putting together some acts that are a little bit different than what you get when you have all people. So I would summarize by saying, we've been looking in a number of specific areas that are very promising, but what we really hope to do by having the robot available, just yesterday we made it available on our website, so you can just, go and buy one. We hope to find all kinds of new ideas for how to adapt Spot by adding a sensor or adding a mechanical gizmo. We have an arm, but you can make all sorts of things that go on it. And then we're going to learn about how you could use it.
Okay. So what was like the hardest thing you had to design to make Spot work like the way it does now?
It's really challenging to make these robots have enough versatility or generality. It's not too hard to make a machine to do exactly one thing, but when you want it to do everything, unfortunately, people make it look easy. Like we all grow up, no one teaches us how to pick up a jar or hold your mouse, right? Somehow it just happens, and we're really good at it, and it makes it look easy. But all these things are incredibly hard to get machines to do. So part of the job is to get people who are using them to understand that we don't have the range of capabilities that people and animals have, even though we would like. The robots are getting better and better in that regard. Getting enough power and efficiency so that the robots can operate for a long period of time without needing to be recharged every 5 or 10 minutes. I think Spot goes for about 90 minutes on a recharge. That's pretty good, but longer would be better. And of course, getting them to be robust and reliable enough so that they keep working no matter what you do to them. And that's an ongoing process.
Okay. So how difficult was it to turn, Spot into a product? Because, originally, I guess it was sort of like a design that, you were trying to implement, but not really to sell. So how difficult was it, to make it into something you could sell to just people?
It's an entire culture switch to go from, we used to be pretty much an R&D company that would develop a very new thing in our laboratory as a prototype. Usually we didn't worry about what it cost because it was more important to get it done quickly and really make it work than it was to try and make a low cost object. They didn't really have to be too reliable because we had them in the lab and we had people there to fix them. In fact, our model was to plan on having the robots fixed nearly every day. And we would always encourage people, don't worry about whether that's dangerous to the robot. Go for it. And if it breaks, we'll fix it. When you make a product, it's totally different, right? We're not there every day to fix it. You want it to be lower cost. We wanted to manufacture this in the United States, which is what we're doing. And there's a bunch of challenges there because the US manufacturing, at least for complicated electromechanical systems, you have to really hunt around to find the right people. I think we have found them, but there was a number of challenges there. And then getting them trained up on the sophistications in the machine and get testing and all that. So there's one kind of thing that's all technical, which is what I've been talking about. But there's also all the red tape of making something that passes the rules for electrical safety, general safety, not doing emissions that are going to interfere with your radio or computer or whatever that's going on. So we had to jump through a lot of hurdles to do that. And now there's sales, getting a product. It's not a product unless you're selling it. So now we built up a sales team and have materials and training materials, repair group and all that. So, there's the part that's making the prototype work in the lab. And then there's the world of things to make it into a product. And we're just learning how to do that.
Okay. I mean, do you like making into a product more, or just like trying to fix it every day?
One of the points I was going to make that's a little separate from this question, but I'll get back to this question is, I'm just one guy at a company that's full of engineers, and every one of these projects involves a real team effort. And if I had advice for any of you, it would be, develop your skills. That's really important. But also learn to work in a team. Because in a team, it's not only your skills, but it's the skills of every other person, and you get the full benefit of that. So at Boston Dynamics, we have, some pretty big teams with lots of skilled people that are working together. And this team knows this kind of thing, and that team knows that kind of thing. So when we get to productizing, we have people who are both very good and live and breathe making the product. I would probably rather be tinkering with the new prototype to make the wild new thing happen than to make the one that works absolutely reliably every day. But it's very exciting for the company to be at a place where some of the things that started out as wild ideas are now available to be used, around the world. We have about 150 spots in users' hands, and we hope to get that to be a much larger number now that we've released it for sale. So that's pretty exciting too.
Yeah. So we have a question from the audience.
Would you rather be the tinkerer or the product maker?
I mean, I'm like more of a tinker. I like adding new stuff, new features, breaking things essentially. So we have like a question from the audience. So a person said, how does Spot know where to go? So how to navigate by itself?
So we have a bunch of different modes for Spot. The most basic mode has a person who has a joystick and a radio control and gives simple steering directions. I say simple because the robot has computers on board that are always working to keep the robot balanced, to control its speed and direction. So the robot, it's like you have two people where one is telling the other one, go that way, stop, go faster. But the robot then, the second person has to interpret all that in order to actually do it. So that's the lowest level. But Spot also has cameras built into it, so it can see forward, backwards, and on both sides. And we can also have a laser rangefinder on the robot, although it's not required. And once you have those, you can build a map of the environment and then give a route and let the robot travel along the route on its own. And I think we have a YouTube, I don't have anything today, but I think we have a YouTube video that shows Spot navigating an environment where it's doing it all on its own after the map was built up. And it can do that all day long, where it just keeps going until the battery runs out, you change the battery, and then it goes again.
Gotcha. Okay. So there's another question. Someone said, Atlas, the walking robot that can jump, I think roll now too. So they said Atlas has, it has 2 legs, and then Spot has 4 legs. So why did you decide to go 4 legs?
I think the key idea is that the number of legs is only a practical decision. My work on the pogo stick in the early days was meant to say, what are the basics? And once you have the basics solved, then other things tell you how many legs to have. Atlas was originally built in order to test equipment that people were going to use. So we wanted it to be the shape of a person, and that's why we gave it 2 legs.
Right.
4 legs is very practical because you get a lot of strength in the legs compared to the weight of the body. So the legs can be lighter and the body can be heavier, and that's a good morphology. But I think all numbers of legs are potentially a useful configuration, and it just depends really on what you're trying to do.
Yeah, that's right. Okay. So the next question is, what are some neat applications, for Spot that, you could tell the viewers?
We've been concentrating on the 3 biggest applications we've been concentrating are on construction site monitoring, where you go into a site with some kind of sensor And then you can do scans to get either 3D data or you take 360 imagery, and then you can measure the progress of the thing. Some construction companies have thousands of ongoing construction projects going at a single time, and they have to keep track of that. And you know, these days with the pandemic going on, you can't just hop on a plane and go fly to your site and go do an inspection. So the idea that you could have a robot remotely available, either to drive it around and collect data, or to have it do scans and send them up to the cloud, and then you review them online. All those models are possibilities. So one application are various parts of the construction world. Another one is doing industrial site inspection, like I showed you in that video a little earlier. And I think that's going to be the biggest way of using our robots, because many of these sites were built 50 or 75 years ago, before there was widespread use of networking and sensors and electronic sensors. And you may think you could put a sensor at every gauge or every place that there could possibly be a leak, but you really can't. And so having a robot that can travel around those sites and collect data could be really valuable. And then lastly, there's logistics. I don't know if you're an Amazon or a Walmart or a Home Depot user, but almost all these places will ship stuff to your house. And if you look behind the scenes at how they get the product from the manufacturers to wherever it has to go and then to your house, there's just a huge amount of tasks in there. And we're starting to develop machines that can move boxes around, unload a truck full of boxes or pallets of boxes, back them up in shelves, recombine the orders in order to meet the needs of a particular user, and then ship them off. And I think that's a huge business that's growing at leaps and bounds. And I think that's not a spot application, but it's an application for some of the other robots we're building.
Yeah. Okay. So next question is, so Spot was in the news about, Brigham and Women's, what was it doing there?
So we got a phone call from one of the people who works in the emergency room there. He's one of the managers, and they asked whether there was a way to use robots to help them with their job. And at that time, it was very early on. They had a triage tent set up outside the emergency room at Brigham and Women's Hospital, and they wanted to see, the normal way of using the triage tent was that if a person came in, they would have them sit down, and then either a nurse or some other healthcare worker would gown up and put on masks and go and ask them a few questions and interact with them. And then they would decide. And they were wondering whether we could use a robot to do that. So we took one of the Spot robots in a very quick amount of time, maybe 2 weeks. We put some shells on it so that it could be decontaminated. I don't have a picture here, but if you look in the media, you can see the shells. We put a communication device on it so that the robot could walk in, and then the remote nurse or doctor could have a two-way conversation with the patient and decide what to do. But we also built some sensors. We currently have working a remote respiration rate sensor and temperature sensor. And we're working on blood oxygenization and a heart rate sensor. So the idea is to be able to measure the vitals of the patient remotely without having to have anybody exposed. And the whole idea is to keep the doctors and nurses from having any unnecessary exposure, especially when they don't know what the status is. It's been interesting though, and let's see, a couple of things have been interesting. I wondered whether the people would be afraid of the robot, because if you read in the media talks about people being afraid. And so they asked the patients, would you rather have a doctor or nurse, or are you willing to let the robot? And not a single person that they've tested it on was afraid of the robot. They all said, yeah, sure, give me the robot. That sounds like an easy way to do it. The other thing that's been interesting is I think this use of a robot to keep people out of harm's way has really opened the door for people thinking more broadly about the positive things you could use a robot to do, and it not all be about fear of the robot or taking jobs. It's really open people's ideas to the opportunities. So I'm really excited.
Yeah. Yeah, I mean, like, there's a lot of things, can help people with, like in case of, emergencies like this pandemic. So, it's really nice.
You bet.
Yeah, so you like once said, the robots would be bigger than the internet. So why do you believe that?
The internet is an amazing thing. It lets you reach out and touch all the knowledge in the world. But how about reaching out and touching all the stuff in the world? I mean, that seems to me to be really big. So let me show the last video I have here. This is me. This is before the pandemic. This is me on an airplane flying from Boston to California. And while we're over Chicago, I hooked up to the onboard Wi-Fi system. That's an actual screenshot from the system. And I had someone back at the lab started up the Spot robot. And here I am driving it around. I was 2,000 miles away.
Yeah.
And in real time, driving the robot around, even with the crummy network connection. So it's not hard to imagine a day where using this kind of robotics, you can, and of course it's bigger than the internet, but it requires the internet. You can go around the world and manipulate and handle and touch everything that there is out there. And that's really a fascinating and big opportunity. Don't get me wrong, we're not there yet. We have to really refine things, and there's going to have to be a lot of comms, communications progress and other things. But it's just really around the corner, and I'm excited by that. So that's what I meant.
Okay. So I mean, the company, Boston Dynamics, it looks really cool. New technologies you guys are always coming up with. So I'm not an engineer yet, but so what are the other things like someone could do at the company? So what other things people could work there for?
There's a broad range of things that people do at our company, especially since we've become a product company. So we have a lot of employees. So there's HR, right? There's staff who find good employees, interview them, hire them, make them, train them once they're at the company, make them, happy with their job and do all the support things needed to have employees working. There's the business side of the operation, collecting money, paying money to, to our vendors and to our employees and things like that. So it's a whole business side that's a totally non-technical in sense of robotics, although obviously you have to know things there. We haven't had that much of a PR type part of our operation. We've really let YouTube and the internet do that, but now we're starting to build up that side of things. So if you're good at communicating or telling a story or things like that, there's a role for those kinds of people. And then there's there's managing the inventory of all the parts that go into the robots. There's testing the robots. You don't have to be an engineer to test the robots, although obviously there's skills involved.
To understand things.
So there's a wide range. Every kind of job you can imagine, we probably have someone doing, and most companies are like that.
All right. So what kind of impact do you think robotics will have in the future? So
let me start by saying some of the things that I don't think it'll have. I don't believe in a dystopian future where robots have taken over the world. Where people sit in an armchair, sort of isolated and helpless. I think the world is going to stay roughly like it is, where what do people care about? We care about our families, we care about our jobs, we care about food and socializing and love and making money and having interesting things to do. None of that's going to change, I don't believe.
Okay.
But are robots going to be useful? I think as robots become more and more capable, they'll be incredibly useful. They'll help us take care of the disabled and the elderly. I think we'll have them working in factories, doing very dangerous jobs, the dull, dirty, and dangerous tasks that now some people have to do, robots can do. And finally, at some point, we'll have them in our homes, doing chores for us. So there's a lot of impact from all of that, short of the world being turned upside down, which I don't believe in, even though Hollywood likes to tell that story.
Yeah.
What do you think?
So,
I was going to say, that was a great question to end on. We're already running out of time, which is, it went by very quickly. And always enjoy seeing some videos from Boston Dynamics. That's very cool. And Shiny did a great job asking questions. I do want to mention that we ran a drone camp last summer with Boston Public School students, and it was sponsored by Amazon Robotics. And Cheyenne participated, and he built his own drone from scratch. We're going to be offering that again this summer. So if you're interested, just send a note to info@massrobotics.org. We'd be happy to send you some information about that. This is the last of our current series of robot stories. Thank you very much for joining and watching these. It's been a lot of fun putting them on and having our students ask some great questions. If you'd like to learn more about the robotics in the state of Massachusetts, please visit the state's website. It's www.masstech.org/robotics. And with that, I just want to wrap it up as we're coming on a quarter to the hour. We try to keep these to 45 minutes. We're going to end with just a short video, but thank you all for joining us. And we look forward to putting on more of these types of sessions in the future. Thanks.
Thank you, Tom.
A robot is an extension of human capability.
It feels like the future. It's very exciting.
You will see everything from drones to self-driving vehicles, walking robots, and we're excited that it's being developed here in Massachusetts. We have the breadth of talent, the investor community.
We have the facilities to design it, fabricate it, test.
It's just a great environment for robotics.